I really wanted some help with your organic experiments, so another one I'm going to do is we're going to look at the recrystallization of benzoic acid and to determine its melting point. So what's the whole point of this experiment? What is recrystallization? So we're starting off with a mixture, okay? And some of this mixture is benzoic acid and some of it is impurities. An example of an impurity you could use is charcoal. We're going to use a technique called recrystallization to purify our sample of benzoic acid. I'm going to test to see how good we were at purifying our benzoic acid out of the sample by determining its melting point. So let's start with step 1, recrystallization. What we're trying to do here is we're trying to separate the impurities from the benzoic acid based on their solubility. Because our impurities like charcoal are going to be insoluble, we're going to be able to filter them out. Step 1, we're going to dissolve this whole mixture in a minimal amount of hot water. This is going to create what's called a saturated solution. And this is going to ensure that we have a really high yield of benzoic acid. In other words, we're going to isolate as much benzoic acid as we possibly can. Ensure you keep this mixture really hot. You're going to quickly do a step called hot filtration. This step of hot filtration is going to remove any insoluble impurities. Benzoic acid and other impurities are soluble and they will pass through the filter paper. If the solution cools, crystals may form in your filter paper, so a way to fix this is to add a little bit more hot water. Once you've done your hot filtration step and removed any of the insoluble impurities, then we're going to cool the solution. To rapidly cool this mixture is to use an ice bath. This step also helps us to maximize our yield of benzoic acid at the end. Next step we're going to do is now cold filtration. And this is going to help us to remove any soluble impurities. You can also use vacuum filtration here to speed up the process, and hopefully your benzoic acid crystals will form in your filter paper. And then your last step of recrystallization is drying. You can wash your crystals now with deionized water and this will remove any remaining impurities. Transfer those crystals that you have made onto a clock glass and then you can put it in the oven for drying. Remember here that the dryness is essential before you do the melting point. So now you have your sample of hopefully purified benzoic acid, but how do we know if we were successful in our recrystallization technique? That's why we do step 2, determining the melting point. So the melting point of a substance is when a substance changes from a solid back to a liquid. Pure benzoic acid we know is going to melt at the narrow temperature 122 degrees Celsius. If we have any impurities left in our sample, we're going to see that the melting point will melt over a range of broader and lower temperatures. So melting points is a characteristic that we can use to help us identify different substances. So that's how we're going to use it to determine how good we were at our purification technique here in this experiment. Do be able to draw a label diagram of the setup. We're going to use an aluminium block where you're going to place your benzoic acid crystals. Your thermometer there is so we can check the temperature at which the melting point is determined. And also make sure that you have some sort of heat source like a hot plate or a Bunsen burner underneath. As always, if anybody has any questions about the experiment or other areas of the Leaving Cert Chemistry exam, do let me know. Your exam is on Tuesday, but I'm going to try to get through as much content as I possibly can before I sit that. For more Leaving Cert tips.